Okay, parts lists. If you're using a program like SolidWorks, or if you're using Inventor to create your assembly drawings, there will be a parts list or bill of materials dialog box that allows you to build that automatically. So if you're going to use a section type drawing for your assembly drawing, it is necessary not only to show the cut surfaces, but also distinguish between adjacent parts. You do this by using your section lines in opposite directions. Okay, so here at the top housing, the lines are going down to the right, and this one is going down to the left. Okay, so this distinguishes this part from that part. You notice that when you're using an assembly drawing. Now, if I go back to the previous example in this presentation, we can see how that technique is done here. So we can tell these mating parts together from each other by how they are hatched in different directions. Stock parts. When you're doing stuff with Inventor or SolidWorks, you can use stock parts, which, parts that come, they're automatically generated. Okay, other assemblies. Okay, a working drawing assembly is a combined detail and assembly drawing. That's what we really mean by working drawings. I think in our class right here, what we're going to do is we're going to create detailed drawings just the way you always have for me as your homework assignments. For the projects, you're going to create detailed drawings on individual sheets, and then you'll also create for me an assembly drawing for the projects. Okay, we're not really going to do working drawings where we're combining details and assemblies on one drawings. I think it just doesn't fit with how we're going to do things. Next, working drawing formats. There are two general methods for grouping detailed parts on sheets. One is to show the detail, one per sheet. This is typically preferred, but if you had a bunch of small little parts, like again, I'm going to use the example of tool design. This is an assembly jig, for instance. Okay, so they can put all of these detailed pieces on one drawing. Detailed drawing transmittal. This talks about what we've been doing all semester. I've been asking you from the get-go to make me files of your drawings in the PDF format. You submit them to the Dropbox so I can grade them. So PDF allows us, that's a portable document format, allows us to move documents back and forth, just like we've been doing all semester. And some of the final points about drawings too, the title and record strips. I'm not going to be too picky about this, but these are the proper things to have on a drawing. It's the name of the object, the name and address of the manufacturer, the name and address of the purchasing company, if any, signature of the person who made the drawing, so it's drawn by here, and then we have a drafting checker right here too. Signature of the chief draft, whatever the company needs in terms of drawing approval to get drawings released, those names will appear on the drawing, and what the scale of the drawing, and then what the number is. Usually over here, that's where you got the block that says whether or not it's a third angle projection or a first angle projection. Checking drawings. In most companies, they'll have a drafting checker. A drafting checker is somebody who has a lot of experience in drafting, and he would systematically review the drawing for any errors. He would look for soundness of design with reference to function, strength, materials, economy, manufacturability, serviceability, ease of assembly and repair, lubrication, and so on. He's going to scrutinize the choice of the views, whether you're using a partial view for something, an auxiliary view, what your sections look like, lettering, and so He's going to check all of the dimensions, make sure there's tolerances on everything, and make sure the dimensions are feasible with special reference to repetition, ambiguity, legibility, emissions. He's going to be looking for errors, finish marks, etc., etc. Special attention should be given to the tolerances. Are the tolerances reasonable? Standard parts. In the interest of economy, I mean, if you're going to use a screw, you don't really need to design a detailed drawing of the screw, okay? If you can find the screw in McMaster-Carr, for instance, catalog, by all means, use that part. And I would call out the part just as you found it in the McMaster-Carr, for example, for a part number, for instance. And in which case, you wouldn't need a drawing for it, no, would you? Because it's a special part. And your drawing tells you where to source the part, McMaster-Carr. Okay, so any notes with special references should be clear, and the wording, and it should be legible. Clearances. Moving parts should be checked in all possible positions to ensure movement and freedom. And then the title and form information. It all has to be correct. Drawing revisions. In any manufacturing environment, there will always be changes to production parts based on new technology, based on lesson learned, based on, just fits, anything. Okay, so what you need is a record of revisions. Those are usually shown in the upper right-hand corner. And again, it depends on the company you're working for and how they manage their engineering changes. Any changes or additions to a drawing are tracked by a revision number. A symbol can be added to the drawing showing the item affected by the revision. And finally, our last slide here is simplified drawings. We don't really want to use simplified drawings because, it's a way to make them a little bit easier, a little less practical, but that's really not the focus of this course. Okay, thank you for listening. There's going to be another movie about your projects, which is going to be starting right now. Thank you.